For years you've been working with fractions, but I don't know how much exposure you've had to working with fractions within fractions. So I think that this right here is an important problem. We're going to simplify this whole big expression where we're adding two fractions in the numerator of a bigger fraction, and we're subtracting two fractions in the denominator of that bigger fraction. There's two really good methods for solving a problem like this. So I'm going to break it up into method 1 and method 2. For method 1, first I'm just going to start by rewriting the problem. We have 2/3 plus 5/6 over 7/6 minus 1/2. Well, ever since you started working with fractions, you've always been taught that when you're adding or subtracting fractions, you need to come up with a common denominator. So in method number 1, let's just look at the numerator and come up with a common denominator in that numerator. So we need to think about what the smallest number is that 3 and 6 both go evenly into. And that number is 6. Well, the second fraction already has a denominator of 6, so we don't need to do anything to it. The first fraction, we need to take that denominator of 3 and turn it into a 6. So we need to multiply the denominator of that fraction by 2. But we can't just multiply the denominator of the fraction, because then we'd be changing the value of that fraction. So if we multiply the denominator by 2, we also need to multiply the numerator by 2. So what we're really doing is we're just multiplying that fraction by 2 over 2, which is the same thing as just multiplying that fraction by 1. Now let's look at the denominator of the fraction. The denominators are 6 and 2. So the common denominator of 6 and 2 is 6 again. The first fraction already has a denominator of 6, so we don't need to do anything to that one. The second fraction, we need to multiply 2 times 3 to get 6. And again, we can't just multiply the denominator by 3, we need to multiply the numerator by 3 also. So now what we have is, on the top, we have 4/6 plus 5/6 over, and then in the denominator we have 7/6 minus 3/6. Now that we have a common denominator on the top, I can add those two fractions. 4/6 plus 5/6 is 9/6. Now we also have two fractions in the denominator that have common denominators, so we can subtract those. 7/6 minus 3/6 is 4/6. We can simplify each of these fractions if we want to, but I think that the next thing I want to do is just rewrite this division problem. You don't usually see division of fractions written this way. You normally see it like 9/6 and then the division symbol and then 4/6. If you think back to when you first learned about division of fractions, you learned that when you're dividing fractions, you need to take the second fraction, multiply the first one by its reciprocal. So 9/6 divided by 4/6 is the same thing as 9/6 times the reciprocal of 4/6, which is 6 over 4. Now we can either multiply the numerators, multiply the denominators, and simplify later, or we can simplify now, which I think is a good habit to get into. I see a 6 in the numerator and a 6 in the denominator. 6 over 6 is just 1, so I'm going to cancel out those terms, and what I'm left with is 9/4. So when we take this whole big problem with fractions inside of fractions and we simplify it, we're going to get 9/4. We should still get 9/4 when we try to simplify this problem using the second method, but the second method might just be a method that you prefer. I think it's a little bit shorter and more concise. So for method 2, I'm going to start the same way again and just rewrite the problem. So the original problem was 2/3 plus 5/6 all over 7/6 minus 1/2. For our next step, we're still going to be looking at common denominators, but instead of looking at the numerator of this big fraction and the denominator of this big fraction as two separate problems, we're going to look at the denominators of every single fraction within this whole big expression. So I need the common denominator of 3, 6, 6, and 2. Well, when I think about the smallest number that 3, 6, 6, and 2 all go into evenly, it's 6 again. So what I'm going to do is I'm going to take this numerator of my big fraction and multiply it by 6, and the denominator of my big fraction and multiply it by 6. I'm allowed to do that because all I'm doing is taking my expression and multiplying by 6 over 6, which is equivalent to 1. Well, I've seen a lot of times students have trouble multiplying fractions by a whole number, so I just want to remind you that when I say that I'm multiplying by 6, I'm really multiplying by 6 over 1. It's just the numerators that get multiplied by 6, not the denominators. So I'm going to change my 6's into 6 over 1, just so that you remember the rules of how to multiply fractions. The other thing that might be nice for you to see, we're going to have to distribute the 6 over 1 to both of these terms. So sometimes I find it easier to just rewrite my 6 over 1 next to each of these terms so that I remember exactly what I'm doing. So instead of writing the 6 over 1 here, I'm going to multiply both terms in the numerator of my big fraction by 6 over 1. Then I'm going to do the same thing in the denominator. Multiply both of those terms by 6 over 1. Now I just need to go through and simplify each fraction, and what you'll see is we'll end up with something that we can simplify and get our final answer really quickly. So I have 6 over 1 times 2 over 3. Again, if I want to, I could multiply the numerators, multiply the denominators, and simplify later, but I think it's a good habit to simplify right now. I see 6 over 3. I have a 6 in the numerator and a 3 in the denominator. Well, 6 over 3 equals 2. So I'm going to cross out my 6 and my 3 and leave myself with a 2. So what I'm really doing is just 2 times 2 over 1, which is 4, plus 5 over 6 times 6 over 1. Well, I see a 6 in the numerator and a 6 in the denominator. 6 divided by 6 is just 1, so I'm going to cancel those out. And what I have left is 5 over 1, which is 5. Now I have some nice whole numbers in the numerator so that I don't have to worry about fractions anymore. Now I get to the denominator, and again, when I'm doing 6 over 1 times 7 over 6, I see a 6 in the numerator and a 6 in the denominator. 6 over 6 is 1, so I'm going to cancel those out. And what I'm left with is 7 over 1, which is 7. And finally, 1/2 times 6 over 1. I can simplify my 6 in the numerator with my 2 in the denominator. 6 divided by 2 is 3. So what I have is 1 times 3 over 1, which is 3. And then all I have to do is just do some simple arithmetic, and I have my final answer. 4 plus 5 is 9. 7 minus 3 is 4. So as you can see, both methods involve finding a common denominator, but choose the one that you like, and this is how you can face any future problems where you see fractions inside of fractions.